For example 23, we're going to be looking at a couple real-world situation problems and apply the order of operations with decimals. So we're going to be creating some expressions that represent the verbal statements that were given, and we're going to try to solve problems along with that. In our first problem here, we see that a hot air balloon ascended at 7/10 meters per second for 8 seconds. It then descended at 5/10 meters per second for 6 seconds. We want to find the overall change in altitude. Now we're trying to find the overall change, so we could end up with a positive change or a negative change here. And the first piece of information that we're given is that it went up 7/10 meters per second for 8 seconds. And we know that it went up because that was ascended. So to show 7/10 meters per second for 8 seconds, that would be 7/10 times 8. So 7/10 times 8, that gives us the amount that the hot air balloon ascended. It says it then descended 5/10 meters per second for 6 seconds. So to show descending, we're going to add a negative 5/10 times 6 seconds. So for every second, it drops down or it descends 5/10. That is why we have this negative here. And now we would just follow our operation rules. We're going to do the multiplication steps first, and then we will combine our answers together. So for this one here, we would multiply 7 by 8, and that gives us 56. But there was one decimal place, so that is 5 6/10, plus 5 times 6 is 30, and it's a negative times a positive, so that is a negative. But there was also one decimal place, so that's actually a -3. So now we know that the plane ascended 5 6/10 meters, but then descended 3 meters. So we have a positive plus a negative. We're going to subtract these two. So that would be 5 6/10 minus 3. And that leaves us with 2 6/10. And it is a positive 2 6/10. So to find the overall change in altitude here, we could say that the hot air balloon ascended a total of 2 6/10 meters. We could say the overall change in altitude was 2 6/10 meters. Those are two ways that we could represent this. If it were negative, when we use the word change or when we're talking about the change, we would just put that negative in, or we could use a negative verb like descended. But in this case, it was positive, so we could say that the hot air balloon ascended 2.6 meters. Next example, we're going to be looking at a sales tax type problem. And a tax is something that's getting added on. And even if we didn't know that, we could tell by the words in this problem that it is going to be some type of addition. So in our problem here, it says that an electronic game system costs $399 plus a 4% sales tax. We're trying to find the total cost of the game. So you're going to add the $399, which is the original cost, plus the sales tax that gets added on. So if we were to set this up as an expression, we have our original cost of $399 plus the 4% sales tax, and that gives us our total. We need to first figure out what 4% of 399 is. If we were looking at 4% of 399, well, that means we're going to multiply 4% by 399, but we need to first change this into a decimal. So as a decimal, 4% We will move it over 2 spaces. That becomes 0.04. So now our expression is our 399 total, or our original cost, plus 4/10 or 4/100 times 399. That's how we could figure out what the sales tax would be, what 4% of 399 is. To work that out, we could just set it up as 399 times 4. When we multiply, we have 4 times 9 is 36. We carry the 3. 4 times 9 again is 36, plus 3 is 39. We carry the 3 again. 4 times 3 is 12, plus 3 is 15. There were 2 decimal places, so that becomes 1596. So we are left with $399 plus $15.96, and that gives us our total. So we could add these together to get our total. And because there's no decimals in the 399, we could just add the two integers together. We could add 399 plus 15. So 399 plus 15, that gives us 414. And then we could just bring over our change of 96 cents. So the total cost of the system would be $414.96. The next type of example problem that we're going to be looking at deals with percent change. And percent change is a way of comparing two pieces of data. So we're going to be comparing a new number compared to an old number. And there's two things that percent change can be. Percent change can be positive or it could be negative. If the number increases from the original number to the new number, then you're going to have a positive change. And if the number decreases, you will have a negative change. So in this problem, it says that over a 10-year period, the population of a city changed from 3.2 million to 2.8 million. So the original population was 3.2 million, and it went down to 2.8 million. So we're going to end up with a negative percent change in this problem. To find percent change, there is a special formula that can be used to help us find percent change. You take the new amount and subtract the original amount from that, and then you divide it by the original amount. That would end up giving us a decimal, and then we're going to multiply that by 100 to make it a percent. So in this problem, we'll plug in here for new and original. The new amount is 2.8 million. So that is 2.8 minus the original amount of 3.2 million. And that's going to be all over 3.2. So the first thing we want to do here is simplify the top part, and that's 2.8 minus 3.2. Because it's subtraction, I'm going to rewrite it as 2.8 plus a negative 3.2. And again, that is all over the original of 3.2. Now we're adding with different signs, which means we actually subtract. So if we took 3.2 minus that 2.8 and we borrow here, that becomes 0.4. So we are left with 4/10 over 3 and 2/10. Now we would have to divide. A fraction is a division problem here, so we're going to divide that 0.4 by that 3.2. If we set this up, the 0.4 goes inside, and our 3.2 is on the outside. We have to move the decimal place one place. 32 cannot go into 4, so we add a 0. 32 goes into 40 one time. That is 32. we are left with an 8. And 32 goes into 82 times. That would give us 64. That leaves us with 16. And we would add another 0 and bring it down. That leaves us with 5. And that would be evenly. 5 times 32 does give us 160. So we have a terminating decimal here. So this 2.8 minus 3.2 divided by 3.2, that leaves us with 0.125. We now have to change that into a decimal by multiplying it by 100. And if we're multiplying by 100, that means we're just going to move the decimal place 2 places to the right. And this is going to be equal to 12.5%. But in our original problem, it was a decrease, and you could see here that this negative 3.2 was bigger than 2.8, which makes that a negative. We were left with a negative over a positive. So our answer here would be a negative 12.5% change. And there's 2 ways that we could read the change. I could say that the percent change was a negative 12.5%. Or I could use a negative verb, and I wouldn't use the negative sign. I could say the population decreased by 12.5%, or 12.5%, or 12.5%.